the gradient and y-intercepts of the line below. Guys, do you notice that this equation, as it was given to you, is in standard form? Y equals minus 5x plus 1. Guys, there's standard form, eh? Y equals mx plus c. When it's in standard form, they've given you the gradient. There it is, minus 5. And they've given you the y-intercepts. There it is, plus 1. So the answer is this one here. Okay, understand this, grade 9s. When they give you an equation already in standard form, they have given you the gradient and they have given you the y-intercept. They have not given you the x-intercept. I have no idea where this one's going to cross the x-axis. To find that, you have to go and make y naught, and then you can find it. Okay, but I do know that it's going to cut the y-axis at 1, and I do know that it has a gradient or a slope of minus 5. So it's going to slope this way, and it's going through the plus 1 on the y-axis. Number 35, the gradient and y-intercept of this one. This is much more difficult because is this equation here in standard form? No. So what I did was I went and got it into standard form just using my grade 8 equations. Okay, get into standard form, and then the m and the c are obvious. So here we go. I just got the y on its own and the x and the constant there, divided everything by 3. There's my gradient and there's my constant. So your answer was the bottom one. Number 36. Again, they want the gradient and y-intercept. Alright, a weird equation here, but no problem. It's got no constant. So I get into standard form. There it is. Divide both by 2. So you end up with y is equal to 3 over 2x. Okay, if there's no constant, what does it actually mean? It means plus 0, hey? So the y-intercept is 0. But, yeah, and the gradient is 3 over 2. So there's the answer down there. But guys, we know that this goes through the origin, eh? Because it's got no constant. So not only is the y-intercept 0, but the x-intercept is also 0. This line goes through the origin. A line parallel to the line below. Grade 9s, you have to understand that if two lines are parallel, it means that the gradients of those two lines are the same. Alright, so here's the line they're talking about. Look at its gradient is negative 2. Do you see that? So now which of these lines here, these 4 below, which of them also have a gradient of minus 2? Well, the first one does. This one's got a gradient of positive 2, this one's got a gradient of a half, this one's got a gradient of negative a half. Okay, so these two lines here are parallel because they have the same gradient. Okay, again they want to know which one of these lines here is parallel to this one. Is this in standard form? No. So I have no idea what the gradient of this line is. So your first job is to get this equation here into standard form. Okay, so here it is, same thing again. Get the y on its own, x's and constants, divide everything by 3. There's the line in standard form. So there's the gradient, negative 4 over 3. Alright, so which one of these lines here has a gradient of negative 4 over 3? And there it is, the second one. I don't care about anything else. I don't care about the plus 2. I just care about that gradient. If the gradients are the same, the lines are parallel. Number 39. A line perpendicular to the line below. Okay, let me give you a quick lesson on perpendicular lines. Okay, if that is the gradient of one line, then the gradient of another line perpendicular to this one will be this. You take that fraction, you flip it upside down, and you change the sign. You see? So a line with this gradient will be perpendicular to another line with that gradient. Okay, what happens if your gradient is negative 3 over 2? What will the gradient of the perpendicular line be? Okay, again, flip it upside down and change the sign. Positive 2 over 3. Don't forget to change the sign, always. What about this one? If your gradient is negative 6, what will the gradient of a perpendicular line be? Well, negative 6 means negative 6 over 1. Eh? So flip it upside down and you're going to get 1 over 6. Do you agree? And change the sign so it's positive. And lastly, what happens if your gradient is 1? Isn't 1 the same as 1 over 1? So when you flip that upside down, it stays 1 over 1. So it stays 1, the gradient, but it changes sign. So negative 1. Okay, so having said that, let's look at this question. A line perpendicular to this line here. Well, what's the gradient of this line here? Negative 2. So come, what's the negative reciprocal? 2 over 1 will become 1 over 2 and it'll become positive. Eh? So there it is there. It's this fourth one. Oh no, sorry, third one. Check the gradients. It's flipped upside down and it's got a different sign. There's your answer. I'll let you read that. And the last one, they want a line perpendicular to this. What's its gradient? 1. Eh? There's nothing in front of the x, so you know it's 1x. So it's what we just discussed. 1 over 1, when you flip it, it's still 1 over 1, but change the sign. So it's the one with a gradient of negative 1, which is the first one.